Have you ever wondered how a poll of just 1,000 people can possibly predict what an entire country is thinking? I mean, it seems like magic, right? But it's not. It's actually a really powerful scientific tool called sampling, and it's how we turn tiny clues into huge, confident conclusions. So today, we're going to pull back the curtain and see exactly how it all works.
So here's the game plan. First, we're going to tackle the big, obvious problem, why asking everyone is pretty much impossible. Then, we'll see how just one single random guess can be, well, a little misleading. But you're going to want to stick around, because after that, we'll uncover this amazing pattern that turns a simple guess into a reliable statistical guarantee.
All right, so let's just dive right into the fundamental challenge. You know, in a perfect world, we'd have all the data we could ever want. But let's be real, the world is messy, and getting that perfect information is usually way too hard, if not impossible. Okay, put yourself in this situation. Imagine you're a director at a big company. How in the world you figure out what every single employee is thinking? Or, let's say, something really important like their average salary. Well, the answer is surprisingly simple, but it's also kind of profound. You don't ask everyone. You can't. It would take forever and cost a fortune. Instead, you take a sample. Let's make this super concrete with an example. Meet Electronics Associates Incorporated. We'll just call them EAI. Now, they've got 2,500 managers and one big question. What's the average salary around here? The problem is asking all 2,500 of them is just not going to happen.
Okay, before we go any further, we got to get two key terms down. The population is the whole enchilada. That's all 2,500 EAI managers. The sample is just a small slice of that enchilada, the little group we actually go out and talk to. Our entire goal here is to use that small slice to understand the whole thing.
So where do we even begin? Well, we start with just a single guess. Let's see what happens when we dip our net into this big ocean of data for the very first time. You see, the absolute key to getting a good sample is all about fairness. We can't just ask the managers who sit near the entrance or the ones who look like they're having a good day. No. In a simple random sample, every single one of those 2,500 managers has a perfectly equal, totally unbiased chance of getting picked. Okay, so EAI puts this idea into practice. They do a random draw and pull out the names of 30 managers. Now, don't worry about reading every single number on this slide. The big idea is that this table is the real salary data for those 30 people. This is our very first piece of evidence.
So we crunch the numbers for those 30 salaries and boom, we get this number. $51,814. This is our first shot, our first real estimate of what the entire company might be earning on average.
You know, in the world of stats, this kind of single number guess actually has a name. It's called a point estimate. It's our best single shot at guessing the true average salary for all 2,500 managers. But how good is it? How much can we really trust this one number?
And that question, can we really trust this one number? That's the whole ballgame. A single guess is a start for sure, but what if we just got lucky? Or what if we got unlucky? To figure that out, we need to see what happens when we guess more than once. A lot more.
And this is the question that just changes everything. Because luck is always a part of it, right? What if, just by random chance, we picked 30 managers who were all on the high end of the pay scale or the low end? Our answer would be completely different. So let's run a little simulation. Imagine we do this whole thing, not once, but 500 different times. Each time, we pick a brand new, random sample of 30 managers. Now, this slide just shows some of those results. The exact numbers don't matter. What's absolutely crucial to see is that every single time we get a slightly different average. Our first guess of $51,814 was just one of hundreds of possibilities. Okay, and this is where things get really, really cool. If we take all 500 of those different answers, each one its own separate guess, and we plot them on a chart, something amazing starts to happen. Out of what seems like total random chaos, this clear, beautiful pattern starts to emerge. This isn't just noise. There's a hidden order here.
And believe me, this pattern is no accident. It's actually a fundamental law of statistics, and it's the key that unlocks our ability to go from just guessing to actually being confident.
So this gorgeous bell-shaped pattern you're seeing, it has a name, the sampling distribution. Think of it like a map of every possible average we could have gotten. It shows us which results are super common and which are really rare. It's what turns random chance into a predictable science.
And this is where the real magic comes in, thanks to a little something called the central limit theorem.
It says that it doesn't even matter what the distribution of salaries looks like for the whole company. It could be lopsided, it could be flat, it could be totally weird.
Because the central limit theorem guarantees that no matter what that original shape is, look at those three wacky shapes up top. The distribution of the sample averages will almost always form that clean, predictable bell curve. See how as you go down the rows, they all start to look more and more like that perfect bell shape at the bottom? That is the theorem, right there in action. It's incredible.
All right, so this brings us to the home stretch. From guess to confidence. How do we take this amazing theoretical pattern and actually use it to solve our real-world problem back at EAI? Okay, let's bring it all back home to our friends at EIA. Now, just for the sake of this explanation, I'm going to let you in on a little secret. The actual, true average salary for all 2,500 managers is $51,800. And as you can see, that true number is sitting right there in the center of our bell curve. Our first guess of $51,814, it was really close. It was just one of the many possible points on this predictable curve. And because we know the exact shape of this curve, we can start asking some really precise questions. Like, what were the odds that our single sample of 30 people would land within $500 of the real answer? Well, the math tells us it's just over 50%. It's basically a coin flip. And if you're making a big business decision, a coin flip is definitely not good enough.
So, what's the fix? How do we get better odds? Simple. We increase our sample size. Just look at the difference here. On the left, that's our curve for samples of 30. It's kind of wide and flat. But on the right, that's the curve for samples of 100. See how it's taller and narrower, and everything is squeezed much more tightly around the true average? The variation just shrinks.
And this is the big payoff right here. By bumping our sample up from just 30 people to 100, our chances of being within $500 of the true salary skyrocket from a 50-50 coin flip to a nearly 80% guarantee. And that, my friends, is the incredible power of sampling. A little more data can dramatically shrink our uncertainty and give us real, actual confidence.
So the very next time you see a political poll, or a study on the news that mentions a margin of error, you'll know exactly what's going on behind the scenes. That little number isn't an admission of failure. It's a statement of confidence. A confidence that's born from the predictable, powerful, and kind of beautiful pattern of the sampling distribution.